Welcome back to Learning Flask. In the last video, we looked at the Flask app we'll build in this course and the tools we'll need to do it. In this video, we'll start by installing a text editor. A text editor is where we'll write code. A popular text editor is Sublime Text. Sublime is available for OS X, Linux, and Windows. It can be downloaded and used for free for as long as you like, and is recommended to purchase a license. To install Sublime, we'll go to sublimetext.com and click the download link at the top of the page. From there, choose the installer for your operating system and install the program on your computer. After installing, open up Sublime and you'll see a window that looks like this. You can start typing in this file. To create another file, go to File New, and this will create a new file. Once you're ready to save a file, go to File, Save, and save the file to your computer. Now, as we get further along in web development, we'll typically have multiple files open at the same time. For example, I have a Python file and an HTML file open here in Sublime. Now, if I wanted to look at a CSS file, I would have to switch to my file manager, navigate to the folder where it lives, and then switch back to Sublime to open it up. This is time-consuming and will probably take even more time as the project gets bigger with more files. So instead of wasting time switching back and forth between the file manager and Sublime, Sublime provides a way to both edit files and navigate folders in one view. To do this, open up Sublime, go to File Open, and in the Open window, instead of clicking on a file, click on the folder you're working with. In my case, my files live in a folder called Latitude. Then go to the View menu, Sidebar, Show Sidebar, and a file manager should show up on the left-hand side of the text editor. You can now use this file manager to quickly find files and edit them in Sublime rather than switching back and forth between two different windows. So congratulations, you've installed Sublime and you had a look at how it works. In the next video, we'll see how to install and use a command line interface. Welcome back. In the last video, we saw how to install a text editor. In this video, we'll see how to use a command line interface. So the text editor is where we'll write the code. The command line is where we'll type commands to run the code. For OS X and Linux, there should already be a command line program installed called Terminal. So on a Mac, you can just click on the spotlight and type in Terminal. For Windows, we'll need to install a command line program called Cygwin. You can install it by going to cygwin.com/install.html. So after opening up Terminal, you'll see a window that looks like this. There are a few common commands that we'll use over and over again, so let's take a look at them now. pwd prints the current working directory. ls lists the files in the current directory. ls-al lists all the files and folders in the current directory. cd navigates into a directory. cd ... goes back up one level. mkdir makes a new directory. And touch creates a new file. So those are 7 common commands. There are many more commands that can be used to do things like copy files and move files and deleting files. Check out this book to learn more about the commands and make full use of the command line. You can access it at cli.learncodethehardway.org/book. Great, you have a command line interface running on your computer and you know how to use it. We'll use Terminal or Cygwin to install the rest of the tools below. In the next video, we'll see how to get started with version control. Welcome back. In the last video, we saw how to use a command line interface. In this video, we'll talk about version control. As you write more code, it's good practice to keep checkpoints of your code along the way. This practice is called version control. Version control is useful to keep track of your own code and especially useful when collaborating with other developers. A popular version control software is Git. So let's install that next. To install Git, go to this website and follow the installation instructions for your operating system. After installing Git, you'll need to configure it with your name and email address. This is important so that Git knows that checkpoints along the way are being made by you. To do this, first type git config -- global user.name and then your name. Then type git config -- global user.email and then your email. GitHub is an online service that lets you host your projects that use Git. The advantage to hosting your projects on GitHub is to 1. Back up your code online, and 2. Make it easy to share your code with others so that they can collaborate with you. Furthermore, GitHub is now the largest code hosting service in the world, and having a strong GitHub profile with good projects is a great way for you to get noticed by others. To get started with GitHub, first go to github.com/join and sign up for a free account. Then go to this page, help.github.com/articles/generating SSH keys, and follow the steps here to finish setting up your new GitHub account. Great, you're now set up with Git and GitHub. We'll get into details of how to use Git and GitHub as we develop the web application. For now, having Git installed in a GitHub account means that we are good to go. In the next video, we'll see how to install a database. Welcome back. In the last video, we got set up with version control with Git and GitHub. In this video, we'll install a database. We'll use PostgreSQL as a relational database to store the Flask app's data. To install Postgres, go to postgresql.org/download and follow the instructions for your operating system. I used an app called Postgres app, which I found on this download page for Mac. Once you download Postgres, you'll need to create a new user account and password and sign in. Once you've finished doing both these things, create a new database for the Flask app. Call it Learning Flask. So the way you do this is you type create database Learning Flask, semicolon, you press enter, and this creates a new database. We'll come back to this later on. In this video, we saw how to get set up with Postgres. We'll get into the details of how exactly to use Postgres more as we develop the web application further. In the next video, we'll see how to install Flask. Welcome back to Learning Flask. In the last video, we installed a database. In this video, we'll install Flask. We'll use virtual env to install Flask. Virtual env is a tool that creates isolated Python development environments on your computer. So why is this useful? Say you see a Python library that you want to try out. If you install this library system-wide, you run the risk of messing up other libraries you've installed. Instead, you can use virtual env to first create an isolated environment and then safely install the library inside this environment without affecting the rest of your computer. You can then keep this virtual environment around for more development work, or simply delete it when you're finished trying it out. Either way, your system remains organized and clutter-free. To install virtual env, type pip install virtual env. I already have virtual env installed, so that's why it's returning this output. If you get an error here, it's likely that pip is not installed on your computer. So to install pip, go to this website and follow the instructions for your operating system. So once you have virtual env installed, first create a new folder named Learning Flask and change directories inside of it. So that's mkdir Learning Flask, cd Learning Flask. Then once you're inside this folder, type the command virtual env venv. Virtual env is creating a new folder named venv that contains a fresh copy of Python and the package installer pip. Once you've done this, activate your new virtual environment so you can begin working inside of it. Type source venv/bin/activate. You can see that we're inside the isolated environment because of the venv that shows up in front of the prompt. Now that we're inside the isolated environment, we can safely install Flask without affecting the rest of the computer. So type pip install Flask. Here we see pip installing Flask and its dependencies. All right, nice job. You have Flask installed on your development environment, and even better, you installed Flask using a virtual environment to keep things clean without affecting the rest of your computer. We did this using virtual env. In the next video, we'll finish things up by setting up a deployment environment. Welcome back. In the last video, we saw how to install Flask. In this video, we'll talk about how to set up a deployment environment. The final thing we need here is a simple way to deploy the Flask application. That is a way to put the Flask application up online so that people can see it. A popular deployment service is Heroku. Heroku is free to start using, with paid options as you start storing more and more data or using more computing resources. To get started with Heroku, go to this URL and sign up for a free account. Once you've done that, go ahead and install the Heroku toolbelt. Go to toolbelt.heroku.com and download it. The Heroku toolbelt is a set of 3 command line tools that we'll use to interface with Heroku. Lastly, log into Heroku from the command line using Heroku login. Fill in your email and password, and you're all set. We'll get into the details of how to deploy to Heroku as we develop the application. For now, having the Heroku toolbelt installed and signing into your Heroku account from the command line means that we're all good to go. In the next video, we'll take a look at what we've done so far. Welcome back. In the last video, we got set up with Heroku. In this video, we'll review what we've learned so far. So you installed 6 tools that are needed to build web applications with Flask. To review, these tools are a text editor, a terminal, version control, a database, Flask itself, and a deployment setup. Together, these 6 tools, along with your web browser, form your development environment. So how do they all work together? The workflow starts on your computer. You use a text editor to write your code, and you use the command line to run that code. As you write your code, you keep track of it using Git, and you store your code on GitHub. When your application is ready to share with others, you deploy your code to Heroku. At this point, users can now go to your application's URL and view the site. So congratulations on setting up your development environment. Let's continue on to start learning how to build web apps with Flask. Hi, I'm Lalith Polapathy, and welcome to Learning Flask by Pact Publishing. I've been doing web development for the past 5 years. I picked up Flask 3 years ago, and I've really enjoyed how quick it is to learn and how powerful it can be when building complex web apps. I've written articles about using Flask, and in addition to that, I've done several side projects that use Flask as well. The purpose of this course is to teach you how to develop custom web applications using the Flask web framework. To demonstrate Flask in action, we'll build a location-based service. We'll take what we learned in each section and keep adding more features to this app, and by the end of this course, you'll have built a Flask app that lets users sign up, log in, and log out, as well as display places of interest around a particular location. There are 7 sections in this course. In the first section, we'll set up a development environment. There are a few tools needed to build web apps like a text editor, version control, and a database, so we'll get all that set up here. In the second section, we'll begin building the location-based service, starting with just the homepage. In section 3, we'll add a database to the app and start storing data. In sections 4, 5, and 6, we'll build an authentication system and authorization system from scratch. We'll let users sign up, log in, and log out of the app, as well as control access to certain pages depending on whether a user is logged in. Finally, in section 7, we'll add location-based features to this app. We'll add a map and data from a Wikipedia API to do this. Before beginning, you should have done some work with Python and be familiar with HTML and CSS. If you're already familiar with that, you're ready for this course. Now that we've set up a development environment, let's go ahead and start building a Flask app. We'll start in this section by building a homepage with mostly static content. At the end, we'll have a workflow that we can generalize to build more complex, dynamic pages in the rest of the Flask app. In this video, we'll start by setting up the files and folders needed for the app. Let's start by creating a couple folders and files to keep the web app organized. As a first step, let's get back into the isolated development environment we created when we installed Flask. In the terminal, type cd learning Flask to change directories into the learning Flask folder. Then type source venv bin activate. Now that we've entered and activated the Python environment, let's create a few folders and files inside of it. Create a folder named static, mkdir static. This is where we'll put the Flask app's CSS, JavaScript files, and images. So let's create folders for each of these two. cd static, mkdir CSS, mkdir.js, mkdir image. Alright, create another folder named templates. This is where we'll store the app's HTML files. So let's go back up one level, cd .. mkdir templates. Next, create an empty Python file named routes.py. This is where we'll write the app's main code. So touch routes.py. Finally, create a file named readme.md. This is where we can put information about the app like what it does, how to contribute, and so forth. So touch readme.md. In this video, we set up the files and folders needed for the Flask app. Your app folder should now look like this. Now, how do all these files fit together? We'll take a look at this in the next video. Welcome back. In the last video, we created the files and folders for a Flask app. In this video, we'll see how these files and folders fit together. In order to do this, let's trace what happens when a user visits a page in the Flask app. The cycle starts with the user opening his browser, typing a URL, and pressing enter. So step 1, when the user presses enter, the browser issues a request for that URL. Step 2, the request hits routes.py. Routes.py has code that maps the URL to a Python function. Step 3, the Python function finds the correct HTML file living in the templates folder. Step 4, this HTML file fetches CSS, JavaScript, or images it needs from the static folder. Step 5, rendered HTML is sent back to routes.py. Step 6, routes.py sends the HTML back to the browser, and the page loads and the user sees it. This sequence is called the request-response cycle, and it's how the files and folders in a Flask app connect to each other. Now that we know what a Flask app's files and folders are for and how they fit together, let's begin by making a home page in the next video. Welcome back. In the last video, we talked about the request-response cycle. In this video, we'll start by making a home page for the Flask app. The home page will have an image of the app, a few lines about what the app does, and buttons to sign up or log in. So inside the templates folder, create a new file named index.html. So cd templates, touch index.html. Here's what index.html looks like. I added some starter code here. It starts off with a doc type, a head, which includes 2 CSS files, and a body, which has a header and some content describing the app. Let's think a few steps ahead for a second. Suppose I now want to make another page, say an about page. My website should have a similar style and layout across all of its pages, so that means I would need to copy all of this HTML from this index.html file for this new file that I want to create. It seems pretty wasteful to write all this HTML again when the only part I'd be changing is this small bit of content in the body after the header. Thinking even further, what happens if I need to add a new logo or a CSS file to my website? I would need to go into every one of these pages and then add them manually. This is pretty time-consuming and error-prone. Therefore, instead of repeatedly writing the same HTML in multiple different files, we need a way to write things once. This is what web templates are for. So in this video, we started creating a homepage for the Flask app. In the next video, we'll see what web templates are and how to use them. Welcome back. In the last video, we started creating a homepage. In this video, we'll see how to use web templates to reuse the same HTML across multiple pages. To understand web templates, let's start by breaking apart index.html. Here's what index.html looks like now. So let's begin by making a new file in templates called layout.html. So cd templates touch layout.html. In layout.html, we'll write all the HTML that shouldn't change across pages, like the doc type, the head, and the header of the page. We'll call layout.html the base template. Here's what layout.html looks like. It looks just like what we had in index.html before, except now there's this block content and block part. What's going on here? To answer this question, let's see what index.html looks like now. Index.html inherits the HTML from the base template layout.html, and it fills that content block with its own text. In other words, we wrote all the common HTML in the base template layout.html and defined an empty block named content to be filled in by child templates like index.html. In this way, the base template defines the common elements of the website, while the child elements customize it with their own content. So what are web templates? They are HTML files that contain variables and control flow statements. They solve the problem we faced in the previous video. Rather than writing the same HTML over and over again in multiple web pages, we write the common HTML once in a base template and inherit it and customize it from the child templates. In this way, web templates make your app easier to maintain. So in this video, we talked about what web templates are. In the next video, let's move on to routing. Welcome back. We used web templates to create a home page, but now how do we actually see the home page in the browser? Let's look back at the request response cycle. We just created a template, index.html, and we placed it inside the templates folder. For us to see this page in the browser, we need to map a URL to it, and we do this in routes.py. So let's do this next. Open up routes.py and modify it to look like this. First, import the Flask class and the function render template. Then create a new usable instance of the Flask class and save it into the variable app. Third, map the URL / to the Python function index. The Python function uses the Flask function render template to render index.html. So now when a user types in the URL / the function index will run and return the page index.html. Finally, finish up the file with this if statement. app.run runs the app on a local server. The debug true flag here is set so that we'll see any error messages along the way. So that does it. Go to the command line and type pwd. This is the present working directory, so we're at the top level of the Flask app. And then type python routes.py. So this will start the local server. And as per the output here in the terminal, go to localhost 5000 in the browser, and there's the page. Cool, so we just saw what routing is. In the next video, we'll start adding some static files to this app. Welcome back. In the last video, we talked about routing and ended up seeing the home page in the browser. But where did those styles come from? In this video, let's talk about styling. In the terminal, create a file called main.css inside the static CSS folder. So cd static, cd css, touch main.css. Open up the file, then visit this link and copy the CSS in there and paste it into your main.css file. We want to use the CSS file across all the web pages. This means that we need to add the CSS file to the base template layout.html. Open up layout.html and add this line inside the head element. So replace the static CSS main.css line with this line. So the reason for doing this is rather than hard-coding the file path to main.css, we're using the Flask function url_for to generate a URL for us. Here, url_for is telling Flask to go to the static folder and look for the file main.css. Great, save your changes and go back to the browser and reload the page. The CSS should now be applied and our home pages should look the same. We've accomplished a lot so far. We've gone through a full turn of the request response cycle. So let's trace what we've done. We typed in localhost 5000 into the browser. The browser issued a request for that URL. The request hit routes.py, where the URL / was mapped to the function index. The function index fetched the web template index.html from the templates folder. The web template used a CSS file, so the CSS file was fetched from the static folder. Routes.py then sent all the rendered HTML back to the browser for us to see. In the next video, we'll save this work to GitHub. Now that we've made a home page, we've reached a good stopping point. Let's review the workflow we're following. The workflow starts on your computer. You're using a text editor to write your code, and you're using the command line to run your code. Now, as you write more code, we should keep track of it using Git and store that code on GitHub. When the application is ready to share with others, we should deploy to Heroku so that users can go to that app's URL and view the site. So far, we've finished step 1 by making a home page. So let's proceed with step 2 and push the code up to GitHub. To begin, go to the terminal and shut down the local server by typing Ctrl-C. We'll restart this later when we've added new features. Create a new Git repository. Type git init inside your application. Let's verify that the new Git repository was created. Type ls-al. This command lets you see all files, even hidden ones. And here we see that the .git folder was created, so a new repository was created successfully. Next, let's add the files we changed to this repository. To see what files changed, type git status. The output shows that these were the files that we had modified, and this is right, because these are the ones that we actually did modify earlier. So let's go ahead and add them. Git add routes.py. This command starts tracking changes to the routes.py file. Type git status to double check that the file was added, and there it is in green, the new file routes.py was added. And then go ahead and add the other files that we modified. So git add readme, git add static, git add templates. Type git status one more time to confirm that all these files were added, and they were. Go ahead and commit these new files. Type git commit -m initial commit, and a new snapshot of the project is created. Now all the code is committed to a Git repository locally, so let's get set up with GitHub next. Go to github.com and create a new repository. Type in a name for your repository. I'm naming mine Learning Flask. And then create the repository. And then scroll down and take these 2 lines and copy them into your terminal. The first line connects your local Git repository to the GitHub repo, and the second line actually pushes your code from your local repo to the GitHub repository. The code should be up on GitHub now, so refresh the page and you should see your commits. So those are the common Git commands that we'll use: git status, git add, git commit, git push, and that's the basic sequence we'll be using them in. There's much more you can do with Git, and check out this book to learn how you can make full use of Git and understand it more. Now that the code is under version control and pushed to GitHub, let's take a look at how to deploy the app to Heroku in the next video. The Flask app now works locally on your computer, so let's deploy it to Heroku so that it's available for others to see as well. To deploy it to Heroku, we need to do 3 things. First, install the gunicorn web server. Type pip install gunicorn. Second, create a file named requirements.txt that has a list of the Python libraries we've installed so far. Type pip freeze requirements.txt. And here's the file that was created. Third, add a text file named procfile that tells Heroku to run Flask using gunicorn. Then in Sublime, add this line to procfile. Now that we've done these 3 things, let's create a new Heroku app. In the terminal, type Heroku create. This will create a new subdomain for your app. Mine is called Tranquil Ridge 5048. The Heroku create command creates a new Git remote repository on the Heroku servers. We can push the Flask app to this remote repository using git push Heroku master. But before we do this, let's make sure to commit the new files we added, procfile and requirements.txt. I'm using git status, git add, and git commit, just as we did before. Once the new files are committed, go ahead and deploy the app using git push Heroku master. The app will take a few seconds to deploy, and the app is now live. See what it looks like by typing Heroku open. Heroku open will open a new tab for you, and this app is live for anyone to see. You can copy this URL and share it with others so that they can see your progress so far. As a final step, make sure to push your changes to GitHub as well. Type git push origin master. In this video, we deployed a Flask app to Heroku. In the next video, let's add an about page to the app. Great work! Your Flask app is now live. In making a homepage, you've gone through one complete turn of the request response cycle. You mapped the URL to a Python function in routes.py. The Python function rendered a template living in the templates folder and then sent it back to the browser. The request response cycle is a really helpful guide for making apps. To make sure we really understand it, let's practice it again and add an about page to the app. The About page will have a few lines about what the app does and a button to create an account. To do this, let's repeat the same sequence of steps we used to create the home page. So first, create a new HTML file named about.html. cd into the templates folder and create a new file, about.html. Second, open this file and inherit the boilerplate from the base template layout.html. Use the extends keyword to do this. Then fill in the content block with the about content. Here I'm adding a heading that says about learning Flask and a paragraph with some more information about the app. Remember that in web templates, rather than rewriting the same HTML over and over again, we can write a common HTML once in one base template, layout.html, and then inherit and customize it from child templates, like about.html. Third, let's make this page show up in the browser. Looking at the request response cycle, we've made a new template named about.html and placed it inside the templates folder. In order to see this page in the browser, we need to map a URL to it. We do this in routes.py. So open up routes.py and modify it to look like this. In this code, we map the URL about to the Python function about. The Python function uses render template to render about.html. Now when a user types in the URL /about, the function about will run and return the web template about.html. Fourth, go to the command line and type python routes.py. Then visit localhost 5000 /about in the browser. And there's the new page. So just to review, when you typed in the URL and pressed enter, the browser issued a request for the URL /about. The request hit routes.py, where the URL about was mapped to the Python function about. That function then fetched the web template from the templates folder. The web template used a CSS file, so that CSS was fetched from static. And then routes.py sent the rendered HTML back to the browser for us to see. Now there's one small thing that we can change. If we go back to the home page, notice when we click the Learn More link, nothing happens. This should actually go to the About page, so let's fix that now. Open up index.html, and where the null link used to be, let's use URL4 to generate a link to the About page. So type URL4 about. Cool, reload the page and try it out. Now when you press Learn More, you're taken to the About page as expected. Looking good. Let's save these changes and push the code up to GitHub. Let's confirm what files changed using git status. Then actually add the new files using git add. Confirm that we've added the files using git status again. And now that the files are added, commit them. Use git commit to commit the files. A new snapshot of the project is created with this. We're ready to go. All the code is committed to the Git repo locally, so let's push it up to GitHub. Git push origin master. The files are now up on GitHub. Sixth, deploy the app to Heroku so that the About page is also available for others to see. Deploy the app using Git. Git push Heroku master. Take a few seconds to deploy, and that's it. The app is now live. See what it looks like by typing Heroku open. And there it is. In this video, we created an About page, and in doing so, went through another full turn of the request response cycle. In the next video, let's review what we've done so far. Congratulations, you've written a Flask app from scratch. Let's take a quick look at what we've accomplished so far. To build this app, you've gone through 2 complete turns of the request response cycle. You created a URL and mapped it to a Python function. Then in that Python function, you rendered a template and sent it back to the browser. And once things worked the way you wanted, you saved your code to GitHub and deployed your app to Heroku. We'll continue to use the same workflow in the next sections for more complex pages, namely ones that fetch data from a database. So let's see how to do this in the next section. Welcome to section 3, storing data. In this section, we'll look at how to store a user's name and password into a database. In this particular video, we'll take a look at how to create a table for that data. So far, we built a Flask app containing 2 static pages. In doing so, we started developing a generalizable workflow that we can use to build out the rest of the app. This workflow is summarized by the request response cycle. When you type in a URL and press enter, your request hits routes.py. In routes.py, the URL is mapped to a Python function that fetches a web template and its assets and renders it to HTML. That rendered HTML is sent back to the browser where it displays to the user. The problem with this app so far is that it doesn't do anything interesting. The homepage and the about page look the same for all users. Their content is static. How can we create web pages that are personalized to each user? How can we let users sign up for the app so that they can do things like view places around them? We'll talk about that in this section. To do this, we need a place to safely store a user's data. We can do this with a database. Here's how a database fits into the request response cycle. When a user types in an address and presses enter, the browser issues a request for that URL. The request hits routes.py, where the URL is mapped to a Python function. The Python function can interact with a database. It can write information to the database, like creating a new user. It can read information from the database, like places near a user. The Python function can pass along data from the database to a web template, render it to HTML, and send it back to the browser so that the user can see it. By adding a database, we move beyond static websites and create dynamic websites, where we can safely store user data and render content in pages that is customized to each user. Let's begin by creating a system that lets users sign up for this app. To accomplish this, we need a place to safely store user data. We can do this by setting up a database. There are 4 things we need to do. First, install a database engine. Second, create a new database called Learning Flask. Third, create a new table called users. And fourth, add a new user. We've already completed steps 1 and 2 in the first section. We installed Postgres and created a database called Learning Flask, so we're good to go on those 2. Let's move on to the third step. Inside the Learning Flask database, we need a table where we can safely store users' information. We'll call this table users. The information that we'll want to store are a user's first name, last name, email, and password. Quick note on passwords. Unlike first name, last name, and email, it is not a good idea to simply store passwords as is in plain text in the database. The reason for this is that if someone breaks into your database, they would be able to see all your users' passwords. Not good. One way to defend against this is to encrypt passwords first, and then store that encrypted password into the database. The pwd hash column is short for password hash. We'll take passwords and encrypt them using a hash function and then store that in the database. Flask provides hash functions that we'll use to make this pretty straightforward. Start your Postgres server. Depending on the installation you used, the startup step will be slightly different across different installations. I downloaded Postgres app, so I'm going to open this app and open PSQL. And this opens up a new terminal window for me called PSQL where I can interact with the database. Let's enter the Learning Flask database. In Postgres, we do /c and then the name of the database. Now I'm connected to the Learning Flask database. Create a new users table using the create table statement. The columns to create are UID for the user ID, and then first name, last name, email, and pwd hash. For first name, last name, email, and pwd hash, we're using the varchar data type. This lets us store strings of variable length. And then for the UID column, we're using the serial data type. This will let us generate an ID for each row that automatically increments. More on this in a bit. Using a select statement, confirm that the table was created. And you can see this table is empty. There are no rows in this table just yet. Now that we've created a new users table, let's move on to the fourth step and add a new test user to this table. Let's use an insert into statement to create a new user. We'll want to store encrypted passwords into this table, so this user entry is temporary, just for testing. Now when we run a select statement, we see the table has one row, has one user, and the UID field has auto-incremented. So far we've created a users table in the database. Next, let's connect this database to the Flask app. In the previous video, we created a users table in the database. Next, we need to connect the Flask app to this database so that it can read and write information to it. But it turns out that Flask doesn't come with any of this functionality off the shelf. It only comes with a small set of functions like render template and URL for. This is one reason why Flask is easier to learn than other web frameworks. There's just not as much stuff. Instead of packing in extra functionality like connecting to a database, Flask lets you add it on as needed using extensions. Here's a list of Flask extensions. An extension is a package that adds a specific functionality to a Flask app. And looking through this list, there are extensions for adding in functionality for web forms, sending email, many other common tasks in web application development. To add functionality to communicate with a database, we'll use the Flask SQLAlchemy extension. To use this extension, first get back into the app's isolated Python development environment. Here, I'm in the environment already as shown by venv. If you're not, just type source venv/bin/activate to get back into the isolated Python development environment. So now that we're inside the development environment, let's use pip to install Flask SQLAlchemy. So type pip install Flask SQLAlchemy. If you get any errors at this point, it's likely that others have run into it as well, so the easiest solution is to Google the error for solutions. Now that Flask SQLAlchemy is installed, let's use it to connect Flask to the Postgres database Learning Flask. Open up routes.py and modify it to look like this. With this line, we configure the Flask app to use the Learning Flask database. We specify this using a database URI. This format is the connection string that Flask SQLAlchemy expects. Check out the Flask SQLAlchemy docs for more information on how exactly this works. But with that line, the Flask app is now connected to the database. In the next video, we'll write a user model to interact with this database from Flask. Welcome to the last video of this section. In this video, we'll look at how to write a user model that can interact with the database that we've created so far. What have we done so far? First, inside the Learning Flask database, we created a users table to store user information. Second, we used Flask SQLAlchemy to connect Flask to this database. The last thing we need is a data structure that we can use from the app to read and write to the users table. This data structure is called a model. We'll write this code in a new file called models.py. This way, the model stays separate from the code in routes.py, which maps URLs to functions. So make a new file called models.py. Open models.py in the text editor and add the following code. Let's go through this code line by line. In line 1, we import the SQLAlchemy class from Flask SQLAlchemy. Then in line 4, we create a variable named db containing a new usable instance of the SQLAlchemy class. Then in lines 6 through 12, we create a Python class to model the user's attributes. These are the same as the columns for the user table, so UID, first name, last name, email, and PWD hash. In lines 14 through 18, we create a constructor to set each of these class attributes. A couple of things to note about the constructor. The constructor saves the first name and last name in title case, so the first letter is capitalized. It saves the email address in lowercase to make sure that we can match regardless of how the user types in his credentials on subsequent sign-ins. And notice that we're encrypting the user's passwords right away using the setPassword function and storing that into PWD hash. We use the setPassword function to set a salted hash of the password instead of using a plaintext password itself. SetPassword relies on the function generatePasswordHash, which is a security function we're importing from one of Flask's libraries, workzip. That's on line 2, where we import that generatePasswordHash function. Lastly, to make everything work together, modify routes.py to look like this. First, import the db object from models. Remember, db was the new usable instance of the SQLAlchemy class. Then use db.initApp to initialize the Flask app for using this database setup. And that should do it. We now have a way to read and write to the users table. In the next section, we'll use this functionality to create a user sign-up system. What have we done so far? We created a users table in the database and wrote a user model that we can use to read and write to this table. In this section, we'll create a sign-up page so that we can take in user data and save it to the database. In this particular video, we'll install Flask WTF. Here's how everything will fit together. First, a user will visit the URL signup to create a new account. the page will be retrieved through an HTTP GET request and will load in the browser. Second, the sign-up page will have fields for a user's name, email, and password. The user will fill out the form and press Sign Up. Third, when a user presses Sign Up, the forms will submit to the Flask app through a POST request and will hit routes.py. Fourth, in routes.py, a function will check whether the submitted data is valid. This means checking whether all fields are filled out, whether the email looks like a real email address, and whether the password is longer than 6 characters. Fifth, if any of the submitted data does not pass validation, the sign-up page will load again with helpful error messages so that the user can try again. Otherwise, if all fields are valid, we'll save the user's credentials to the database. The user will be signed in and redirected to the home page. We're going to use the sign-up form to take in a user's data and save it to the database. Now, how do we actually write this form? Remember in the previous section, we saw that instead of packing in extra functionality, Flask lets you add it on as needed using extensions. An extension is a package that adds a specific functionality to a Flask app. To add functionality for web forms, we'll use Flask-WTF. Flask-WTF lets us define forms in Python so we don't need to mess around too much with the HTML. To install Flask-WTF, we'll use the same sequence of commands as we did when adding Flask SQL Alchemy. First, get back into the app's isolated Python development environment. Next, use pip to install Flask-WTF. Now that Flask-WTF is installed, let's use it to create a form in the next video. In the last video, we installed Flask-WTF. In this video, we'll create a form. In order to make a web form using Flask-WTF, we need to do two things. First, we need to set up a backend where we define the form's fields. Second, we need to set up a front end where we display the form's fields to the user. Let's set up the backend first. Flask-WTF lets us define forms in Python, but where should we write this code? We already have routes.py. This file maps URLs to functions. Let's not clutter it up with unrelated code. Instead, let's create a new file named forms.py and write the form there. Then open up forms.py and add the following code to it. First, we import a few helpful classes from Flask-WTF, the base form class, a text field, a password field, and a submit button. Next, we create a new class named signup_form, inheriting from the base form class. And then we create each field we want in the form. Since this is a signup form, there are fields for the first name, last name, email, password, and a submit button. That does it for the backend. We use Flask-WTF to define a form. Let's move on to the front end and get this form to display in the browser in the next video. Now that we've defined the form's fields in forms.py, in this video, let's display the form when a user visits the signup page. In other words, when a user visits the URL signup, a signup page containing this form should show up. This means we need to create a new URL mapping in routes.py and a new web template in the templates folder. This is similar to what we did for the index and about pages. There are a couple of minor additions along the way, so follow along and let's do this together. Open up routes.py and import the newly created form. So from forms, import signup form. Next, configure the form to protect against a security exploit called cross-site request forgery, or CSRF. You can Google CSRF to learn more about this. Type app.secretkey equals development key. Here I define a secret key that Flask-WTF can use to generate secure forms. Then create a new URL mapping in routes.py just as we've done before. So type app.route signup, and then create a function def signup. Inside this function, first create a new usable instance of signup form, and then send this form to a web template named signup.html. This. We haven't made signup.html yet, so let's do that next. Create a new template named signup.html. Remember, we place templates inside the templates folder. So cd templates and touch signup.html. Open up signup.html and add the following code. So first, extend from the parent template layout.html, just as we did with index.html and about.html. To make this look a little bit better, let's do some syntax highlighting for Python. Cool, there we go. Then fill in the content block with code for the signup form. So type block content and end block. Inside this block, start adding the markup for the web form. Add a main element and a div element, and a header that says create an account. Then start a web form using the HTML form element. Notice the form element's action attribute is set to the signup route that we created in routes.py. And then use the form object to generate the rest of the form. Remember, in routes.py, we sent a variable named form to the signup.html template containing a usable instance of the signup form class. Form here refers to that variable. We use it to generate the rest of the form. We start by inserting a hidden tag to protect against CSRF attacks, and then we add each label and field of the form. Here, each label and field is inside its own div class equals form group element, so I'll just copy and paste this structure and create each field of the form. Here's the email field, then the password field, and finally the submit button. Great, we're now ready to see the result of all our work. Run the local development server and visit localhost 5000/signup in the browser. And there's the form. Let's quickly review everything we did so far using the handy guide of the request response cycle. First, we typed in the URL localhost:5000/signup into the browser's address bar and pressed enter. A GET request hit routes.py where the URL/signup was mapped to the function signup. The function signup ran where a variable named form containing a new usable instance of the signup form class was sent to the web template signup.html. Signup.html generated the signup form's HTML markup, and that rendered HTML was sent back to routes.py. Routes.py then sent that rendered HTML back to the browser so that we see the signup page load. And the signup form looks pretty good, except for one problem. When we click that sign up button, we get an error that says method not allowed. So what's going on here? Let's look back at the figure from the beginning of this section to figure it out. If a user visits /signup, this page is retrieved through a GET request. Else, if the user fills in the form and presses sign up, the form submits to the Flask app through a POST request. In Python, this logic can be expressed as an if-else statement. Let's add this to routes.py. Open up routes.py, and first let's import another Flask class that we can use to distinguish between GET and POST requests. It's called request, and I've imported it in line 1. So let's go ahead and use it in the signup function. Add methods equals GET, POST, and then add an if-else statement to distinguish between a GET and POST request. If a form has been submitted, a POST request has happened. So let's just return a string saying success. This is just a temporary placeholder. We'll replace this later. Else, a GET request has happened. So render signup.html as usual. So that should do it. Let's visit localhost:5000/signup again, fill in the form, and click that sign up button. The app now shows success. Let's review everything we did one more time using the request response cycle. First, we typed in the URL /signup into the browser's address bar and pressed enter. A GET request hit routes.py where the URL /signup was mapped to the function signup. The function signup ran. Program execution hit the if-else statement. And since the current HTTP method is get, the code in that else branch ran. A variable named form containing a new usable instance of the signup form class was sent to the web template signup.html. Signup.html generated the signup form's HTML, rendered HTML was sent back to routes.py, and routes.py sent that rendered HTML back to the browser, which we see when the page loads. When we filled out the form and submitted it by clicking sign up, a post request hit routes.py. Remember, in the web template signup.html, we had specified the form's action to be /signup, so the post request hits the signup function. The function signup runs one more time, this time running the code in the if branch, and the string success is sent back to the browser. In this video, we saw how to render a form. In the next video, we'll validate form data. Now that we've rendered the form, in this video, we will validate the form data. When a user visits /signup, he'll see the signup form and can fill it out with his info. But what happens when a user fills out the form with incorrect or missing information? For example, what happens if this email is invalid and I have a missing password? The form still submits successfully in this situation. This is not good. We need a way to check the user's input so that it won't cause problems later on. We can check form data using validators. Flask WTF comes with several useful validators that we can use. The most basic validator is data required, and it checks that the field is filled in. So first import the data required validator. Then for each field, make a list named validators and add data required to that list. This validator will make sure that none of the fields are empty. So if a user fills in each field of the form and submits it, the validation check will return true. If data does not exist for one or more fields, the validation check will return false. Looking back at this figure, if any validation check fails, the signup page should reload with a helpful error message so that the user can fix the mistake and try again. Flask makes it really easy to give this sort of feedback. Let's write some code first and then I'll explain what's happening. In routes.py, after a user posts the form, if any validation check returns false, we should reload the signup page with a helpful error message. So let's add if form.validate equals false, reload the signup page, else the form data is good and we can continue working with it, so return success. With this code, the form now won't just submit when incorrect data has been submitted. It will just reload the form. Next, modify signup.html so that it displays helpful error messages that the user can use to fix mistakes and try again. In signup.html, write the following code. So between the label and the first name field, add this code. If form.firstname.errors, then end that if statement. Loop through them and display them as HTML p elements. So basically this code checks if there are any error messages with the first name field. If there are, loop through them and display them in a p element. There's some CSS in main.css that makes these error messages red. It targets that error message class. And that should do it. Can use this same code for the other fields as well. Just make sure to use the correct field. So do the same for the last name field, the email field, and the password field. Finally, visit the signup page, leave the fields blank, and click sign up, and there are the error messages. So pretty cool that they show up, but they're kind of generic. So let's customize these error messages. Go to forms.py and add your own messages inside data required, like this. So here I am changing the error message shown when the first name field is not filled out to say, please enter your first name. Likewise, for the last name field, the email field, and the password field. Visit the signup page again, leave the fields blank, and click sign up. And now there are the custom error messages. We accomplished a lot in this video. We added validators to the form to make sure that we get valid data from the user. Now I know we went through a lot of material, so make sure you feel comfortable with it, and we'll practice it again in the next video. In the last video, we implemented some useful form validation. Let's add 2 more in this video. We used the data required validator to make sure that each field was filled out. So what else should we validate? We should probably make sure that the info entered in the email field is actually an email address. We can do this with the email validator. Let's follow the same steps as we did with the data required validator. Open up forms.py and import the email validator. Then go to the email field and append the email validator to the validators list. Give a useful error message here inside the parentheses. Let's see if this works. Visit the sign up page again, enter an invalid email, and click sign up. And there's the error message. The email validator is working as expected. Now what else can we validate? We should probably make sure that the password is longer than 6 characters. We don't want short, insecure passwords. So let's implement this. We can do this with the length validator. Open up forms.py again and import the length validator. Go to the password field and append the length validator to the validators list. First, specify what the minimum length you want with the min argument, and then using the message argument, give a useful error message here. Let's see if this works. Visit the sign up page one more time, enter a short password, less than 6 characters, and click sign up. And there's the error message. The length validator is working as expected. In this video, we added 2 validators to a form to make sure that correct data gets sent to the Flask app. In the next video, we'll save this data to a database. Now that we've handled the case where there is incorrect data submitted, in this video, let's handle the case where correct data is submitted. So far, we're using a temporary placeholder string that says success when all the fields exist. Let's replace it with real code. When a form has all valid data and is submitted, we want to save that data into the database. To do this, let's add the following code to routes.py. First, import the user class from models.py. Then create a new usable instance of the user object and initialize it with data from the signup form. So initialize it here. And for each field of the form, you can fetch the data that was submitted by using the .data attribute. And then insert the new user object into the users table and save it. We can do this using db session add and db session commit. And that's it. Now when we enter valid data in the signup form, a new record should get saved to the database. So fill out the signup form, click sign up, and you should see success, indicating that the form submitted successfully. You may see an error message here that says no module named psychopg2. If you do, this means that the library psychopg2 is missing, and to fix it, just go to the terminal and use pip to install this missing library by typing pip install psychopg2, and that should fix it, should be set. And then go to Postgres, type select all from users, and there's the user we just signed up. We accomplished a lot in this section. We created a sign-up form where users can enter their data and sign up for the app. We implemented validators to make sure the data was correctly inputted. And if it was, we save it to the users table. So what should we do next? Well, what happens after you log into your Google account or Facebook account? You're signed in and redirected to your profile page or homepage. We'll do this in the next section. In the last section, we built a sign-up page where users can enter their credentials. We added validators to the sign-up form to make sure data was entered correctly, and if it was, we saved that data in the users table. What comes next in this section? There are 3 main things that need to happen. 1, after a user signs up, a session should begin, and he should get redirected to his homepage. 2, Registered users should have the ability to sign in again. 3, they should also be able to sign out. Let's begin with item 1 in this video. First, what is a session? When you sign into an app, the app needs some way of identifying page requests you make so it can serve you your information. It does this by setting a cookie in your browser containing an ID. So after you sign up for an app, the app sets a cookie in your browser containing an ID. Then, on each subsequent page request you make, the ID in that cookie is passed to the app. The app looks up whether the ID maps to valid user credentials. If it does, then the app understands that you're a signed-in user and returns a response with the relevant information. This combination of having an ID stored in your browser that maps to valid user credentials on the server is called a session. Flask has a session object that makes this functionality easy to implement. It stores an ID and a secure cookie on the user's browser. Let's add it to the signup function next. In routes.py, import session, redirect, and URL4 from Flask. We'll use this in the signup function below. So in the signup function, add this line. What this line does is after a new user signs up for the app, it creates a new session. So once a new session is created, the user should get redirected to the home page. To do this, we'll use URL4 along with Flask's redirect function. So replace the placeholder string inside signup with the redirect to the home page. Now we don't have a URL mapping for home yet, so let's create one in routes.py. This is similar to the URL mappings we've created before. We need a template named home.html, so create it in templates. This is also similar to how we've created templates before. Open up home.html and inherit from layout.html. I'll change the syntax highlighting to Python again so it's a little bit easier to read. And then fill out the content block with markup for the home page. So add the main element, a div element, and finally a heading that says home. Let's try all this out. Launch the Flask app, go to localhost 5000, and try out the signup flow. So type in your first name, last name, email, password, click sign up, and you should get redirected to the home page. You can also go to Postgres and check that this record was actually saved in the database. So far, we're able to sign up for the app, and when we do, we're redirected to the home page. In the next video, let's move on to the second item and create a sign-in page. We built the sign-up page in the previous section. Let's move on to the second topic and build a sign-in page too. This is very similar to the sequence of steps we used to create a sign-up page. So there are 3 things we need to do here. First, create a new class named login form in forms.py. Second, create a new URL mapping for /login in routes.py. And third, create a web template in templates to create this form. Let's get started. Open up forms.py and create a new class named login form. The login form class will be similar to the signup form class we created. So inherit from the base form class. There will be 2 fields in this class for a user's email and password. Both fields will have validators on them. The data required validator checks that the field contains data. And the custom error message that it will display is please enter your email address. The email validator will check that the field looks like an email address. And its custom error message will say please enter your email address as well. The second field for the login form will be the password field. So create that here as well and add a validator for data required. Lastly, add a submit field. When this form is submitted, we'll make sure that the user exists in the database and has the correct password. We just created a new class named login form in forms.py. Let's move on and create a new URL mapping for /login in routes.py. So open up routes.py At the top, import login form so that we can use it here. Then create a new URL mapping for /login. It will accept two methods, get and post. And then the login function itself will be similar to the signup function above. If the form has been posted and the validation check fails, then reload the login form. Else, if the form validates, we'll fetch the data from the login form. So collect the email data and the password data. Then, using the email and password data, check whether a user exists in the database with these credentials. So here, user.query.filterby searches the database for a user with that email address. If a user does exist and the password check works out, then log in the user by creating a new session and redirecting to the home page. Else, if a user does not exist in the database with that email and password, then we need to reload the login form. So what this line does is it redirects to the login route, which will trigger the GET request. So we'll just set up the GET right now. If a GET request has been received, we simply render the form. Lastly, let's create the web template login.html so we can see the login form. So create login.html inside the templates directory. Open that up. Login.html is similar to signup.html. So here, extend from layout.html. Inside the content block is where we will write the markup for this login form. I'm just going to switch the syntax highlighting to Python so this is a little easier to read. There we go. And inside the content block, start writing the markup for this login form. Again, pretty similar to the signup form. I set up the main class container, and inside I set up the div section content. Inside this div, add a heading titled login, then use the HTML form element to post to the login route we just set up in routes.py. Inside the form element, use the form object to generate the form. This is very similar to what we did in signup.html. Here, I'm creating a form group for the email field. So first the email label, and then the email field itself. I'll copy that and create another field for the password. Then finally, add the submit button down below. And that should do it. Feel free to add the code to display error messages just as we did in signup.html. Let's try all this out. Go to the terminal, start up the local server, Python routes.py, and visit localhost 5000/login to see the login form. Log in with your credentials to see if it all works. Click sign in and redirects to the home page as expected. The login page is up and running. Let's move on and let users log out of the app. In the last video, we created a login page. In this video, we'll move on and figure out how to let users log out of the app. Now remember, in the previous two videos, we discussed that logging a user in meant creating a new session. Creating a new session meant setting a cookie in the user's browser containing an ID and mapping that ID to a user's credentials. Therefore, logging out a user must mean deleting a session. This means clearing the cookie in the user's browser and removing that mapping to the user's credentials. Flask lets us do this in one line with session.pop. Let's get started. Open up routes.py and create a new URL mapping for /logout. So here we go, creating a new route. Inside this route, we need to do two things. First, use session.pop to delete the cookie, and then redirect to the index route. And that is all that is needed for the logout route. Now, one quick thing before we try all this out and make sure that it works. Let's go to index.html. Remember in line 9 that we have a placeholder for the link to the signup page. Now that we've implemented the signup page functionality, let's update this template to point to the signup page. Delete the placeholder and replace it with URL for signup. Now let's try out the flow. Go to the index page, click the sign up button, and sign up for the app. So type in a first name, a last name, an email, and a password, and click sign up. You should get redirected to the home page as expected. And when you visit /logout, you'll get logged out of the app and redirected to the index page as expected. Congratulations, you made an authentication system from scratch. You implemented a sign-up page, login page, and logout functionality. What's useful about this authentication system is that it's generalizable beyond just this app. You can reuse these steps when you need to add an authentication system to your own Flask apps in the future. Now that an authentication system is in place, we have a few things to look forward to in the next section. We'll make the profile page better, we'll set up authorization and user roles, and we'll implement the location-based service. Let's do it! In the last section, we built an authentication system from scratch. In this section, we'll take a look at authorization. We'll see how to protect the home page, the sign-up page, and the login page. More specifically, in the first video, we'll tackle the problem of why users can visit pages even if they aren't logged in, and why they can still see the sign-up page after they are logged in. We implemented a sign-up page, a login page, and logout functionality. For the sign-up page, if all the fields are valid, the system saves a new record to the database and starts a new session. For the login page, if all the fields are valid, the system checks if the username and password match the ones in the database, and if so, starts a new session. The logout functionality pops the session. In this section, we'll see how to let users access only parts of the application relevant to them. This is called authorization, and that's what we'll talk about in this video. The authentication system we built lets us register and identify people who use the site. While it works, it has two major flaws. Let's take a look at the first flaw. Cool, so let me log out of the app completely. Alright, I'm totally logged out now. But if I type /home into the address bar, I can still access this page. The problem here is that we're currently allowing anyone to access pages that require login. What we want instead is only for users that are logged in to access this protected page. If a user is not logged in, he should be redirected to that login page and enter his credentials in that form. So that's the first flaw. The second flaw. Let me log into the app again. And I get redirected to /home as expected. The problem here is that now when I go back to the sign-up page, I can still see this form. Same is true for the login form, I can still see it. We're currently allowing signed-in users to see the authentication forms. This doesn't make sense either. What we want is only for users that are logged out to see these forms. If a user is logged in, he should be forwarded to the home page. So those are the two flaws in the authentication system right now. Let's solve the first one in the next video. In this video, let's see how we can address the first flaw in the authentication system and control access to the home page. We'll review how the session object can be used to check whether a user is logged in, and then we'll use that session object to protect the home page. Remember, when I'm logged out, I can still access the home page. Instead, what we want is for the user to be redirected to the login page. In other words, if a user is not logged in, he should be redirected to the login page. So how do we determine if a user is logged in? Let's look at the signup function in routes.py. To log in a user, we use this line, session email equals new user.email. In other words, to log in a user, we created a new session. Similar to a Python dictionary, we associated the key email with the user's email in order to create this new session. Therefore, we can use this session object to determine if a user is logged in. If a user is logged in, that key email should exist in this object. On the other hand, if a user is not logged in, the key email wouldn't have been set. It wouldn't exist in that object. So we can check this with a simple if statement. So let's type that out now. If email not in session, return redirect URL for login. Let's trace what happens now if I'm logged out. So I try to go to /home. This if statement runs. It checks if the key email exists in the session object. Since I'm not logged in, the email key is not in the session object. So the code inside this if statement runs, and I get redirected to the login page. All right, let's try it out in the app. First, I'll log out of the app completely. Then I'll try to visit /home. but when I do, I get redirected to the login page. So with that if statement, we fixed the app's first flaw. No longer can I access /home if I'm logged out. That page is now protected. Now that this is taken care of, let's move on and fix the second flaw in the next video. In the last video, we talked about controlling access to the home page. In this video, we'll see how we can control access to the sign-up page and login page. Remember, the second flaw in the authentication system we created was that when I'm logged in, I can still access the sign-up and login pages. What we want instead is that if a user is logged in, he should just be forwarded to the home page. This flaw is sort of the inverse problem of the one we had in the previous video. If a user is logged in, he should be redirected to the home page. So how do we determine if a user is logged in again? Well, the same way we did in the previous video. If a user is logged in, the key email should exist in the session object. Therefore, we can check this with a simple if statement again. If email in session, return redirect URL for home. Let's trace what happens now when I'm logged in. So I log into the app, the key email is added to the session object, and now when I go to /signup, the email key is in the session object. So the code inside this if statement runs, and I get redirected to the home page. We can add the same piece of code to the login page. So if email in session, return redirect URL for home. Let's try out these flows in the browser. So go to the login page and log in to the app. Get redirected to home. And now when you try to visit sign up, you still get redirected to home, just as expected. Same thing if you go to login, you get redirected to home. So now both the sign up page and login page are protected. And we've fixed the app's second flaw. No longer can I access the sign up or login pages if I'm logged in. I get redirected to the home page instead. Now you're probably asking, do I need to write this stuff over and over again to implement an authorization system for each Flask app I create? No, you don't. Remember, Flask doesn't come with much functionality off the shelf. Instead, it lets you add it on as needed using extensions. There's an extension called Flask-Login that lets you do the stuff we covered here and more. So feel free to use this extension in your Flask apps moving forward. But by going through how authentication works from scratch with keeping track of sessions, hopefully you have a better understanding of what's going on behind the scenes so that you're set up to understand Flask-Login or other extensions in your own apps. So nice work! You made a basic authorization system from scratch in this section. You protected the home page from logged out users. Similarly, you protected the sign up and login pages from logged in users. In the next section, we'll build on the home page and add locations. In the last two sections, we created an authentication and authorization system for the app. In this section, we'll complete the home page by retrieving and showing interesting places around a user's location. In the first video of this section, we'll look at the location-based features of the app and prepare to implement them in the next videos. So here's how it works. I type in a location into this form. The app retrieves interesting places around this location and plots it on a map. When I click on a marker, it shows me the name of that location. And when I click on the name, it takes me to the Wikipedia page for that location. We'll use the same workflows and concepts that we've been using in the previous 6 sections, like the request-response cycle, forms, models, and web templates to build this part of the app. We learned a few useful, repeatable workflows in the last few sections. The most important one is the request-response cycle. It traces how a user's request flows through the app and gives a helpful guide to develop each part of an app. So what I'll do now is go back to the home page and trace how my request flows through the app. This narration will help us implement this part of the app in the following videos. Alright, so here's the flow. First, I arrive on the home page. I type my address into a form. Second, I press submit, which posts the form. Third, in routes.py, the code inside the home function receives my address input. Fourth, the home function takes my address and queries for places around it through the model. Fifth, the home function saves the output of that query into a list. Sixth, now that the results are in a list, the home function sends it to the web template home.html. And seventh, home.html displays each list element in the sidebar and on the map. So this is the flow we want to accomplish. In the next video, we will work on implementing this. In the last video, we set some goals for this section. Let's get started here by adding a form for addresses. Remember, when I land on the home page, I type my address into a form. So the first thing we need to do here is create a new form. To do this, first go to forms.py and create a new class named addressForm. So type class addressForm. The address form will have one field for an address, and it's a string field. So you can name it address. And it has a simple presence validator on it, so we can use the data required validator. And the custom error message here can be please enter an address. The form will also have a submit button, so go ahead and type that out here. Next, let's use this form in routes.py. So open up routes.py, and at the top, let's import the new address form from forms, just like this. Then create a new usable instance of address form in the home function. So form equals address form. Now, following the examples in the signup function and login function above, a form has two states, the post and the get. So let's set that up here. So if request method equals post, we should do something. I'll just put pass here for now as a placeholder. Else if the request method is get, we want to render the form. And remember to pass the form object to the template, just like that. Let's go back to the post state. So looking at the examples above, if the validation check fails, then we should just reload the page. So we can set that up by saying if form validate equals false, then just return the template, home.html, and make sure to send the form to the template again. Otherwise, if the validation passes, then we should handle the form submission in some way, and we'll get back to this in the future videos. I'm just going to put pass here as a placeholder. Now, there's actually a bug in this home function, so see if you can spot it and fix it. Otherwise, we'll come back and fix it later. So the form is set up and routes.py is set up. So let's move on to the template home.html. In home.html, we use the form object to generate the form. Again, this is similar to what we did in the templates signup.html and login.html. So rather than type all that code again, I'm just going to copy and paste what I have here so that we can go through it together. As before, in line 1, we extend from layout.html. Then in line 3, we fill in the content block. So inside I have some divs and classes here for basic styling. Lines 12 through 26 are where the address form lives. And it looks pretty similar to the login form and signup form that we had set up earlier. So first add the hidden tag to protect against CSRF, then optionally display any errors that show up. Then in line 22, display the address field. And finally in line 25, display the submit button. Let's try this all out. Visit localhost 5000/home and see if it works. The address form should look like this. And if it does, let's go ahead and move on to the next video and flesh out what happens when the form is posted. In this video, we'll take a look at Wikipedia's Geodata API, and then describe how we can wrap this API by writing a new model in models.py. At a high level, when I type in my address, the code should first take my address, second, query for places around it, and third, return those results. So let's make note of these 3 steps with comments here. First, let's retrieve the address from the form and save it into the variable named address. So address equals form.address.data. Great, done. Next, we need to take this address and search for places around it. How do we do that? Wikipedia actually has several articles labeled with geographic coordinates. It makes this data programmatically available through the Geodata API. So if I wanted to find places around a particular latitude and longitude, here's the URL I would use, and here's the XML output. We can use Wikipedia's Geodata API to query for places around a point. But how do we query for places from Flask? Thinking back to the request response cycle, the controller can optionally interact with a model to retrieve information from a database. This is what we did when we used the user model. So this means we'll need to make a model to query the Wikipedia Geodata API. But where's the database? The users table lived locally on your computer. The Geodata API isn't a table, it's an API that lives on Wikimedia servers. Not a problem. We'll write a model that wraps this API. So wrapping an API sounds more complicated than it is. So let's just dive into the code and we'll clear this all up. So to summarize briefly, we want to use Wikipedia's Geodata API to find places around a point, and we want to make a model that queries the Geodata API. So here's what the code looks like. I'm going to copy and paste it so that we can go through it together again. Starting in lines 4 through 6, I import 3 libraries. First is geocoder, second is urllib2, and third is JSON. Then I create a model named place, and here's what it looks like. There are a few helper functions in here. The address to lat_long function converts an address into a latitude and longitude coordinate. It uses the geocoder package to do this. So geocoder is something you would need to install. So go back to your terminal. Make sure you're in your isolated Python development environment, and then type pip install geocoder. That will install the package and it will help this function work. Then in line 45, there is a query function that searches the Geodata API. It uses the address to lat_long function to convert an address into a latitude and longitude. Then in line 49, it constructs the Geodata API URL and then visits it. So there's the URL. Now this API will return data as a JSON string. So in line 54 and 55, the JSON library is used to convert the string into a Python dictionary. And once you have the data in a Python dictionary, you can just iterate through the results, which is what I'm doing starting in line 57. And then I just return that list at the end. This is the model we'll use to query the Geodata API. We'll use this model in routes.py to query the API and return those results to the template. So first, import the places model at the top, and then in the home function, create a new usable instance of the place model. So p equals place. Convert the address input that you fetched from the form into a latitude and longitude. I'll just name that latitude and longitude my coordinates here. And then query for places around those coordinates using the place model's query function. That does it for querying for places around an address. Let's send these variables along with form to the template home.html. So here's how we do that. Let's remove the placeholder pass and return render template home.html. We'll return the form object, the my coordinates list, and the places list. Nice job. The post logic now works. Let's make sure that the get logic also uses these same variables so that it can expect these when it renders the home.html template. In order for us to do this, let's first initialize these two variables, my coordinates and places, so that they have at least some default values before they enter the if statement. So just make an empty list for places and a default latitude and longitude for my coordinates. And then send the places and my coordinates objects to the home.html template from the get request. So all that means is we can copy this line, paste it in here, and we're good to go. So awesome, the get and post logic is now working. Let's move on to rendering this information in home.html. Now that we're able to query for places around an address, in this video we'll talk about rendering those places in home.html. We've already rendered the form, so let's now figure out how to render the my coordinates and places objects so that they can show up in a map in the template. How do we get a map to show up in the template? Well, there's a JavaScript library called leaflet.js that makes it easy to work with maps. Here's a code example on its home page. And there's a quick start guide that gives instructions on how we can start to use Leaflet in the app. So go ahead and click on that quick start link here. That will take you to the quick start page. And if you scroll down, you'll see instructions on how to include Leaflet's CSS file and JavaScript file and map div element in the page. So let's get started. First, in layout.html, add Leaflet's CSS and JSS files. So by adding it to layout, Leaflet will become available in all the child templates. Then in home.html, let's add a few more things. In line 29, add a new div with an ID map. Leaflet will use this div and place the map inside of it. Then in a new script element, go ahead and add these lines. This JavaScript initializes a new map. Here we set the center of the map to be that my coordinates object we sent from routes.py. And then we loop through the places object to populate a JavaScript array. This may look a little strange, but remember that we can use Jinja templating to generate any markup on the page, including code inside the script element. Let's try this all out. Visit the home page and see if the markers show up on the map. Go ahead and type in an address. But what happens when we press search? It says method not allowed. Well, what does that mean? Let's go back to routes.py and see if we can figure out what happened. In the home function, we have the post and get set up correctly, but it looks like the app.route at the top is missing that methods argument that says what methods this route will permit. Remember, we added this methods argument when we set up the login route. So we're getting this method not allowed error because we're missing this argument here. This is the bug that I was talking about a few videos back. Fortunately, it's an easy fix. Just to add that methods argument back in here saying that both get and post requests are permitted for this route, and we're good to go. Now when I type in an address into the address form and press search, the map markers show up on the map as expected. Let's finish up the home page by displaying a list of places in the sidebar. Open up home.html one more time. In the div.section tabs section, add the code given in lines 9 to 14. Here what I'm doing is looping through the places object and just rendering the place's name and walking time. Okay, back to the browser. When I reload this page, I now see the markers in the map and the locations in the sidebar as expected. And that's it. We created a location-based app using Flask. In the next video, we'll wrap up this course. Let's take a look at what we've done so far. We built a location-based web app from scratch using the Flask web framework. The app uses major features of Flask, such as models, views, controllers, web templates, forms, validations, and even interacting with an API. We used Git to manage our code along the way, and here's a link for how to deploy the app using Heroku. At this point, you have all the ingredients you need to build your own Flask apps and continue your journey in web development. A great place to start is with the Flask extensions registry. Scroll through the list and read what each extension does and see how you could use it to augment this app or create brand new apps. Here are a couple ideas of next directions you could take with the app. And we're done. Thank you for watching this course.